Welcome back. So we are analyzing the circuits using the nodal analysis techniques, and in the previous videos we have seen the circuits where we have only one independent voltage source, or we have a dependent current sources, or we have multiple independent sources. So now we are moving towards a very important concept of supernode. Okay, let's try to understand this concept with the help of an example. So we have this circuit here, and the question is, use the nodal analysis and find the voltages V1 and V2. Okay, the voltages are labeled because there are two nodes here. At the first node, 6 milliampere, 6 kilo ohm, and this voltage source of 6 volt. This is connected. Second node, again, the second terminal of this voltage source, 12 kilo ohm and 4 milliampere are connected, and the reference node is 0 node here. So now, the difference between the earlier circuits and this circuit is that now you have an independent voltage source between the two nodes. Okay, so like if you look here, we have an independent voltage source between nodes V1 and V2. Okay, what will be its impact? For example, if you try to write the equation for V1, assuming that all currents are leaving, okay, so what will be that for the V1? Minus 6 milli, okay, leaving current through 6 kilo, that will be V1 minus 0 divided by 6K. Then the question comes, what is the current through this voltage source? Okay, if you recall that we discussed in the previous video, okay, for this circuit, that if a voltage source is connected between a node and the ground, okay, we can find that node voltage value directly, like V1 minus 0 is equal to 12 volt. Okay, and similarly here. But for this example, now what is the difference? That we have a voltage source between two nodes. Okay, of course we cannot write this like this one, like V1 minus V2 divided by 6. Okay, like this current through this branch. Okay, that will be wrong approach because current cannot be written like this. Now the question becomes how we can add this current component here. We cannot directly find the value of V1 flat. We cannot say that V1 is basically 6 volt, because this node voltage is always calculated with respect to the reference. So I can calculate either with reference to V ground, or I can calculate with reference to V2. So that's why, or I cannot say that V2 is basically minus 6 volt. Again, this will be wrong approach. So for such cases where we have basically an independent or dependent voltage source between two nodes, okay, we make it as a supernode. Okay, what is a supernode? That we will combine those two nodes together, and we will call this thing as our supernode. Okay, now what is the advantage of this supernode? Let's have a look. Okay, so this equation is wrong, we cannot use it. Now what will be the advantage of this supernode? So first thing, whenever you define a supernode, okay, you will write an equation for that supernode. Okay, so here this is connected between V1 and V2, and this is the simple independent voltage source. So we can write that basically the voltage drop between these two nodes, that is basically what? V1 minus, okay, the voltage drop here, V2. This is basically what? Simple 6 volt. So we will write the equation for our supernode. This is basically called supernode equation. Okay, again, remember, we cannot write it like this. V2 minus V1 is equal to 6 volt. If you want to use this thing as a reference, then you must write it as V2 minus V1 is equal to minus 6 volt. Okay, so either write it like this way. So basically this equation and this equation are same, like if you rearrange it, but you cannot write it like this one. Why? Because a positive terminal is connected at V1 and negative is connected at V2. So this is like a type of a typical mistakes that is made while solving circuits with the supernodes. All right, so we have got the equation for the supernode. Then we will write the equation, okay, like the KCL equation, our nodal equation at the supernode. So because we have combined these two together, so basically this branch 6 milliampere 6 kilo ohm was connected here V1, 12 kilo and 4 milliampere was connected here V2, and now these two have become a supernode. So we can write one equation, okay, KCL equation for this supernode. Okay, what will be that basically nodal equation? So we assume that all currents are leaving from the node. Okay, so let's just label them. So 6 milliampere leaving, current through 6 kilo ohm leaving. Okay, so this we already have like written in the form of supernode equation, so no need to define the currents here. So then the current through with reference to V2, 12 kilo ohm, then 4 milliampere. So basically we have currents 1, 2, 3 and 4. Okay, so we will write the equation for these four currents now. So let's go with the one which is basically current 6 milliampere coming to the node 1. So I can write this as minus 6 milli. Then through 6 kilo ohm, that will be what? This node minus this node. So what is this node V1? What is the second node? 0. V1 minus 0 divided by 6k. Then now this is the point here. Because it's the super node, so I will quickly move towards the second node here. And I will add all the currents for that node also. So with reference to V2, what is the current through 12 kilo ohm, which is basically third current. So V2 minus 0, okay, V2, okay, the voltage here minus voltage here, okay, which is 0, okay, or we cannot put it here, okay, just to simplify, when you put it, it's totally fine, divided by the resistor value, which is basically 12 kilo. Then again the current, okay, that is leaving, okay, which is 4 milliampere. So 4 milliampere is equal to 0. So this is basically the nodal equation, KCL equation for the supernode. Okay, so just let's simplify this one. So we can multiply with 12. Okay, why 12? Okay, the maximum one here, please watch the previous videos to understand like why we are multiplying with 12s. Okay, all right, so because this is the lowest common multiplier here, so 6 times 12, that will give me 72. Okay, so we are multiplying basically with 12k. Okay, so milli and k will be cancelled, minus 72 plus 12 divided by 6, that will give me 2 times of v1. 12 and 12 will be cancelled, that will give me v2, and 4 times of 12, that will give me 48 is equal to 0. Let's rearrange it. So I have 2 times of v1 plus v2, and I have minus 72 plus 48. So what is minus 72 plus 48? That will give me minus 24 is equal to 0. Okay, and this thing we can rewrite as 2v1 plus v2 is equal to 24. Simplified equation. So this is my second equation, and this was my basically first equation that we get using the supernode. So two equations to one node, rearrange it and get the values of the variables. So I can say that basically v1 using this equation is basically what, 6 times of v2, right? If we take v2 to the other side. Okay, so let's put that in the second equation here. So again, you can use calculator, Gaussian elimination, whatever technique, just to solve these two simultaneous equations. Okay, so 2 times of v1, 6 plus v2 plus v2. But like if you have two equations, it's very easy to simply using the substitution. Okay, so let's simplify. 6 times 2, 12. 2 times of v2 plus v2 is equal to 24. 2 and plus 1, 3 times of v2 is equal to, this 12 will go to the other side, so that will become 24 minus 12, which is basically 12. So v2 is basically what, 12 divided by 3, that comes out to be 4 volt. Okay, now we can put that here to get our v1. So what will be v1? 6 plus 4, that gives me 10 volt. Okay, so we have got the values, okay, for v1 and v2. Okay, what comes out to be v1, students? 10 volt. Okay, what comes out to be V2, that is basically 4. Okay, and you can cross check. Okay, like if you take the difference like V1 minus V2, so 10 minus 4, it should be 6 volt. Okay, so this is just a cross checking that your calculations are correct. This is the way to solve the circuits with the supernodes. Thank you so much.